The cancellation equations for inverse functions become, in this case, the sine inverse of the sine of x is going to equal x for when x is in between negative pi over 2 and pi over 2 inclusive. Now, the sine of the sine inverse of x is equal to x for when x is in between negative 1 and 1. Now, the inverse sine function, sine inverse, has the domain going from negative 1 to 1, you can see here on the graph, and the range it's going from negative pi over 2 to pi over 2. And its graph here is shown. Now, it is obtained from that of the restricted sine function by the reflection about the graph y is equal to x. Now, we know that the sine function f is continuous, so the inverse sine function is also continuous. We can use implicit differentiation to find the derivative of the inverse sine function, assuming that it is differentiable. So let's go ahead and prove that. All right, so what we want to do is, the first thing we're going to do is we're going to let y equal the sine inverse of x. Okay, and therefore we can say then the sine of y is equal to x. And we know that y has to be in between negative pi over 2 and positive pi over 2. And so now what we're going to do is we're going to differentiate the sine of y, which is equal to x, implicitly with respect to x. Okay, so we're going to obtain the following. So if we're going to differentiate the sine of y, which is equal to x, then that means we're going to get the cosine of y times dy over dx, and the derivative of x is 1. Okay, now if we want to solve for dy over dx, we're going to divide by the cosine of y. So we have dy over dx, which is equal to 1 over the cosine of y. Okay, so now we need to take a look at this denominator. And what does this denominator tell us? Well, we know that now the cosine of y is greater than or equal to 0, since we know that y has to be in between negative pi over 2 and pi over 2. So what does that tell us? Well, when we take a look at the sine squared y plus cosine squared y, and that's equal to 1, we want to solve for the cosine of y. And by doing so, we would subtract the sine squared y to both sides. And then taking the square root of both sides, we get the cosine of y, which is equal to the square root of 1 minus the sine squared y. Okay, now, what do we know about the sine of y? Okay, because this is the same thing as saying the cosine of y, which is equal to 1 minus the sine of y squared. Well, if we take a look back at what we called the sine of y, we said it's going to equal x. So we can replace this sine of y to be x. So therefore, the cosine of y is going to equal 1 minus x squared. And so now we can therefore say that, okay, we know that dy over dx from step number 4 was equal to 1 over the cosine of y. And what do we determine that the cosine of y is? Well, it's the square root of 1 minus x squared. So therefore, this is equal to 1 over the square root of 1 minus x squared. So what we've done is we've created definition number 1. Definition number 1 states that the derivative with respect to x of the sine inverse of x is equal to 1 over the square root of 1 minus x squared, provided that x is in between -1 and 1, but not inclusive.